Hey, how's it going?
Good. How are you doing?
Very good. Thank you for being an interviewee for this mock interview. So this
Hmm.
mock interview is going to mimic a Facebook data scientist analytic interview style.
Hmm.
Um, and this is going to be a 40-minute round. And what we're going to do is we're going to go through some statistics questions for the first 10 minutes,
Hmm.
followed by SQL questions for 15 minutes.
Yeah.
And then we'll use the remainder of the time on an analytic case study. Do you have
Hmm.
any questions on that before we proceed?
No, that sounds good. Thank you.
Okay, awesome. All right, so I'm gonna go ahead and actually use this quarter pad, and feel free to make notes as much as you want. Really, just treat this as though it's your whiteboard. Okay, so let's start with the first question. Can you explain to me what is the beta coefficient of a multivariate regression?
Yeah, for sure. So the beta, if we, um, sorry, let me think about how to frame it. So a multivariate regression describes the relationship between the left-hand side variable, the outcome, um,
Mhm.
and a series of right-hand side variables. Let's call them the independent variables. And the beta coefficient describes how the outcome changes in relationship to changes in the independent variables. So
Okay.
if the independent variable changed by one, and the beta coefficient is on that variable is beta,
Okay.
for example, then the outcome would change by beta, is the
Okay.
way to interpret it.
That makes sense. So how would you actually derive the coefficient of a linear model in this case?
Yeah, there's a sort of a well-known solution analytically, which is that I can write it actually here, which is that the beta vector is x prime y um, times x prime, the inverse of x prime x. And here the um, the x is here x represents the matrix
Yep. Yep.
of the independent variables, and y represents the vector of outcomes.
Yep. Okay. That makes perfect sense. Yeah. So prime in this case would be your transpose, right?
Transpose. Yeah,
Okay.
exactly.
Got it. Now how would you estimate it without using, so I believe what you're using the least squares approach, but is there any other ways, a different way of estimating the beta coefficient?
Um, Yeah, so we could use a maximum likelihood estimation for it, for
Yeah.
example, and do like a optimization exercise on that to maximize the likelihood function.
Okay. Got it. All right. That makes
Mhm.
that makes sense. Sounds
Yeah.
good. All right. So let's talk about the next question. Now, suppose that your target variable is inflated with zero. How would you actually go on about approaching that problem?
Um, so if my data is um, zero, if my target variable is zero inflated, I think the first question that I would ask is there some type of censoring that is happening with the target variable to cause these zeros, or are these zeros like actually the values of that we're interested in?
Got it. That's a really good point. But now,
Mhm.
now let's just presume that in this case, it is an actual value. And
Mhm.
let's say that the presence of zero, so this is actually a non-negative continuous distribution, and the presence of zero is it has is it's about 80% of your observations.
Mhm.
In this case, how would you model this type of data?
Yeah, that's a great question. Um, I believe that there are statistical methods that help you deal with variables that are um, that follow distributions like this. So the probit model or the tobit model, for example, can handle target variables that are particular like this one. If we so that's sort of one statistical modeling approach that we can take. Alternatively, I think just for like sanity checks and understanding the data more, we can also just model the target variable as being 0 versus not, running maybe a regression to see how the beta coefficients look like, and then proceeding with like the original modeling with the original variables.
Okay, got it. All right, that makes sense. Um, Now let's move on to the next question. Can you explain what a confidence interval is of a logistic regression model?
Yeah, so and the confidence interval meaning the confidence intervals on the beta coefficients, I'm assuming.
Yeah, yeah.
Yeah, so the confidence intervals um, represents, so let's say we have like a 95% confidence interval,
Mhm.
and the statistical interpretation of that is that um, they're like 95% of the time, the actual beta coefficient will fall into the confidence interval that we estimated. Um, and and that represents sort of our uncertainty around this variable.
Okay, got it. Now, what if so the beta coefficients of a logistic regression could
Mhm,
either be in log odds or odds ratio, right?
mhm.
Now, let's presume that there's a presence of 0. In either one of those cases, what does that mean? Presence of 0 in the confidence interval, then what would that mean in terms of the statistical significance of its predictor?
Oh, I see. So, um, you you're asking what does it mean if your confidence interval includes 0?
Yes, yes. In
Got
either
it.
in either cases where it's either already in log odds or odds ratio
Hmm.
as a beta coefficient, because the logistic regression model can be in both forms.
Yeah, exactly. Um, so I think my interpretation would be that the beta coefficients are not statistically distinguishable from 0. And yeah, if you were to do a hypothesis testing on that coefficient, then you would not reject the null hypothesis.
Okay, so if the coefficient is already it's in the log odds form, um, would it be possible to have a value of 0?
Oh, I see. Right. So yeah, in that case, I don't think that's possible. Um, right, because it would be, yeah, sorry, if the predictor doesn't isn't correlated with the outcome variable, then the log odds ratio should actually be 1 instead of 0. Um, and it's not actually possible to have a 0 value for that.
Okay. Now, what if it wasn't? What if it was an odds ratio? If the confidence interval has has 1, what does that mean in terms of its statistical significance? So let's just say that the odds ratio confidence interval falls somewhere between um, 0.24 and 1.24. What does it mean in terms of its statistical significance?
Then in which case, because it includes 1, it's if you were to do a hypothesis testing exercise, you would not find that it's statistically significant.
Okay, got it. All right,
Yeah.
thank you. Okay, so we're going to move on to the SQL question.
Mhm.
So I'm going to go ahead and paste the table. So this is a basically a snippet of uh, of the message table set. And it contains your user ID, username, the date, and the message, the number of message sent, and the then the number of message received for a given user on a day-to-day basis. Now, go ahead and try to address the first question, which is for each day, return the name of the user, or in this case, you can return the user ID who received the highest message sent to message received ratio. And this message ratio is your message sent divided by message received.
Got it. Yes, I think the first question that I would, or the first thing that I would check for in this database would be whether there are missing values in either in any of these columns. And in the following analysis, I'm just gonna assume that there aren't any missing values. And the second thing that I would think is important is whether message received could be zero, because then you have a division by zero issue that may need to be addressed.
Okay.
So I'm gonna select. So here I'm creating, I'm selecting the username variable, and I'm also creating a new variable called sent to received ratio, which computes the ratio between message sent and message received. And here I'm marking the message received variable as null if it's equal to zero, so that the division will also result in a null.
Okay.
Oh, and I guess the question that I then want to ask is how we want to treat these users. Do we see them as having the highest ratio?
Mm-hmm. Yeah.
Because
So it's like basically like, okay, for October 1st, 2020, user XYZ had the highest ratio.
I see. So you actually want to set it to like a really high number, so that it would come on top when you sort it.
Yeah, precisely.
Uh,
Off of a given day. So you wanna do some kind of sorting on a given day.
Got it. Okay, in that case, I think marking it as a null may not be the best idea.
Let's actually kind of simplify this for a bit. So let's just presume that there is no zero in the denominator and it's always populated. So how would you go ahead and proceed with that problem then?
Okay, yeah, that sounds good. In that case, I'll just do a simple division to calculate the ratio.
Okay.
And we want to group by date, so that we return one user for each date. And the other question is, are we interested in returning multiple users for each day if they have the same highest ratio for each day?
Good question. So in this case, let's presume that it's just you just return one user in that case.
Okay, so any user in that.
Yeah, any user in that case, yeah.
Okay, yeah, sounds good. Um, I think in this case, I want to do like a window function. So um, I'll create another new variable, which is uh, let's call it rank. Um, and since you said that it's okay to just return one user, I'll calculate row numbers over partition by date, order by the ratio. Mm, um, oh, actually, I don't need to group by date. I just have to select for rank is equal to 1, which is the highest sent to receive ratio. The user with the highest ratio.
Okay. So is this your final solution, or do you want to make any kind of revision?
Yeah, I think that's the final solution.
Okay, got it. Let's so I'm going to give you another question.
Mm-hmm.
So in this case, oops. Now let's just say that for each user, return the first state when the user receives zero message.
Mm-hmm. Return the first state when the user received zero message. And if the user never received zero message, do we then?
In that case, like those users wouldn't matter. So basically, for each user, we just want to see what. So among the users who received zero messages,
Mhm.
when was it that they received that zero message for the first time?
Got it. Yeah, that makes sense. So I would select, let's say we return username. From messages, which is database, and we are only interested in cases where message received is equal to 0. And we also return the first date, which is min date, as date for each user. Oh, actually, sorry, my bad. We only return one observation for each user, so I'm gonna group by username, assuming that both user ID and username are unique.
Okay.
Yeah.
Okay, so what you're basically doing is you're aggregating at the user level
Mhm.
after you apply the filter where you're only looking at the entries that have zero in the
Mhm.
message received.
Mhm.
And then for each of the user, you're extracting the minimum date.
Yeah, exactly.
Okay, got it. All right, so that's pretty much it for the SQL. Let's move on to the next section, which is on the analytic case study.
Mm-hmm.
So this is this question is based on Instagram,
Mm-hmm.
uh, and what Instagram is trying to do is identify users who are influencers. So how would you help Instagram define which users are influencers or not?
Mm-hmm. Yeah, to kind of to get started on this question, I think the first clarifying question maybe that I would ask is how we define a user as an influencer. And I think there might be several ways to defining them. Um, Definition that we could determine that a user is an influencer if they have, a huge amount of influence on Instagram. So maybe if their number of followers exceeds a threshold, then we define them as an influencer. Or if they're if or if they have specific posts that are particularly popular, so maybe not many people follow them, but some of their posts went viral. And so maybe the number of overall views of their posts could also be used as a criteria for determining whether a user is an influencer. The other thing that, moving away from these definitions a little bit is whether a user is being paid for certain content that they post on Instagram. So whether they do any paid ads, and maybe if they do, we can define them as an influencer. Should I proceed with any particular one of these definitions, or?
Well, I think those are good. So number of followers that they have, the number of overall views that they have on posts, and then if they have any paid ads, those are the criteria that you would use to identify if the user is an influencer or not, right?
Yeah.
Okay. So those are the measures. Now, how would you actually bin the users into influencer or not bucket?
Yeah, I guess in order to do that, I would love to understand a little bit more about like what this definition is used for. So is the team in Instagram interested in maybe getting more users into the influencer bucket to promote their business? Or are we trying to cluster users into influencer versus not in order to do some kind of targeted experiment or targeted feature design or things like
So
that?
let's just say that in this case, we want so Instagram, wants to promote, wants to match advertisers with influencers. So
Mm,
of course, we need to identify who the users are. Are they influencers or are they just regular consumers?
mhm,
So this is where you need to help the team define that.
mhm. Yeah, that's very helpful context. And so I guess in that case, I can refine my previous criteria a little bit more. So we are not primarily interested in who is being paid for ads, but instead, like who has the potential to serve as an influencer on Instagram and generate ads revenue for advertisers. Um, yeah, and sorry, what was your previous question?
So like, how would you actually define that criteria saying, okay,
Oh,
these are the users who are influencers?
yeah.
It's
I,
kind of like if you were building like a fraud model saying, okay, this is a fraudster or not. It's
yeah.
very definitive. So similarly, how would you actually do that for the users? Bucket them into influencer or not?
Mm-hmm. How to model. So I think there are two ways of approaching this problem, and I would classify them into, the unsupervised approach versus supervised approach. In the unsupervised approach, we are interested in finding clusters within the user, within the list of users of Instagram, and trying to find the clusters that are that has a huge amount of influence. In the supervised approach, we would essentially try to obtain some type of labels on whether a user is currently an influencer. And then try to classify the remaining users into having the potential to become an influencer versus not.
Okay.
Yeah. So, and I think the key distinction between these two approaches is that in the supervised approach, we have to come up with some ways of creating the label in the first place.
Okay. So how would you go on about creating a label?
Yeah. So if we were proceeding with this approach, one way is to try to collect information on whether they have any paid ads in their current Instagram posts.
Okay.
And I am not 100% sure if this is true, but I remember seeing some of the influencer having these posts that are kind of labeled as advertisement. And if Instagram collects that sort of data, then that could serve as a useful label for this problem.
Got it. Okay. All right. Now I have a follow up. So now let's suppose that you do have this Instagram influencer bucket. Now, how would you go ahead and segment the influencer population? So I'm going to paste the question here.
Yeah, and I imagine that the reason that we want to segment these influencers is maybe to group them into different categories so that advertisers with different needs can be matched to different groups of influencer. Is that right?
Yeah.
Got it. Yeah, and so I think, what type of influence they have would be really the primary variable of interest to us, because we are interested in knowing what type of population they attract. So if they are like a fashion blogger, let me write some potential categories. Maybe they are like a fashion blogger, or they are they post mainly political content, etc. And so their posts, the content of their posts may generate a good signal for what type of crowd they attract. We can also, and so treating this as one of the features is content of posts. And maybe we can do some computer vision type analysis or natural language processing analysis on the content of these posts to extract keywords and group them into categories. The other feature that I have in mind is the type of users that follow them, so their followers. And if their users label themselves in any way on the Instagram profile, then we can get a pretty good sense of how what type of population they're attracting and the potential advertisement revenue they can generate. Yeah, so these are the two main types of features that I can think of at this moment.
So you've identified the signals. Now, with using the signals, how would you actually perform the segmentation itself?
Yeah. So say that we use maybe some machine learning models to analyze their posts and the text that they post, and we can get sort of embeddings of and we can get like embeddings of their content. Then we can perform a unsupervised clustering algorithm to try to group these influencers into different groups. And so one of the simplest models that I can think of is the k-means clustering.
Okay.
There are many modifications of this that serves different purposes. But yeah, this may be a good starting point.
Okay. And one last question, and then we're done with the session. Is how would you evaluate your cluster then?
That's a good question. So evaluation. I think, one way that I can think of on top of my head is if we get some human raters, human labelers, to look at these influencers and then group them into categories.
Okay.
And we can compare the human evaluation with the results that are generated from the algorithms.
Okay. Got it. All right. Yeah, so that wraps up the session. Thank you for being a participant as an interviewee for this mock interview. And I hope you have a good day.
Yeah, thank you so much for the session. Appreciate it.
Yep, thank you.